So today we have Andrea and Jessica Humble-Crofts who are presenting this month's masterclass on making science concepts stick from lists to learning. I'm excited for this one. They've been working hard on it for quite a while now. We've been talking about it for a few months, getting this one up and running. So I'm going to hand over straight over to Jessica and Andrea. And if you can just remember to keep your microphones muted so we don't get any background noise. Alrighty.
All right, well, thank you, Rachel. Hi, everybody, and welcome to this masterclass called Making Science Concepts Stick from Lists to Learning. My name is Jessica Humble-Crofts, and today I'm joined by my great friend and colleague, Andrea. Before we get into it, a little bit about myself. Although I've held many roles throughout my career in education, I am first and foremost a teacher, having spent over 15 years serving primarily as a teacher of science and mathematics in middle and high schools in international schools across 3 continents. A few years into teaching, I began this quest to find and try out pedagogical methods that enhance my students' ability to transfer their understanding whilst developing discipline expertise. This purpose ultimately led me on my concept-based journey, where I became an Erickson and Lanning certified trainer, and currently I serve as the science specialist in the CBCI Institute. I also run concept-based workshops around the world, and I've spent the past few years developing a concept-based inquiry mathematics curriculum. I've also been very fortunate to develop and facilitate several professional learning courses for PLI, including one about concept-based inquiry in science with Andrea, and one on the importance of process across the disciplines.
Hello, everyone. As Jess already mentioned, I'm Andrea Uhl, and thank you for joining us today from all around the world. If you haven't already, put where you're at in the chat. Now, some of you might actually recognize my drawings before you recognize me. I had the privilege of illustrating Rachel French and Carla Marshall's book, Concept-Based Inquiry in Action. As an educator of many years, I've had a lot of firsthand experience of seeing the power of concept-based inquiry in our classrooms and with our students. So when Rachel asked us to facilitate this masterclass, Jessica and I had many ideas. We've been working together for that concept-based inquiry science course, and so we really had to try to narrow it down, and we felt this was something that was quite personal to us both and meaningful in our classrooms. Now, a quick few fun facts about us. Although we both hail from different parts of the world, I'm from the United States living in Germany. Jess is from Australia living in China. We actually met in Germany while working for the Frankfurt International School and while working on the Kalahari project. There we are in the background of that picture, way in the back. We reconnected about 4 years ago when we started working on the CBI mathematics project curriculum. And when we aren't working on our Zoom calls, we love to share a little bit about our lives where we've learned stories such as my time as a youth educator at Disney World, or when Jess was an Aussie leading whitewater rafting trips in Colorado, or driving ice cream trucks or frozen food delivery trucks. So we've had a lot of fun. Now, before we get too much further, I just want to do a quick copyright reminder. Please do not take screenshots or recordings during the masterclass. You usually get a link to the video later. But we would love for you to take notes, and we hope that you will find a lot of things to take notes about. So have that notepad ready. Now, you might be asking, why did we name this class Making Science Concepts Stick from Lists to Learning? Well, I want to take you into a glimpse into my 4th grade classroom about 15 years ago. I mentioned I work at Frankfurt International School. It's in the elementary section, so it's the K to 5. We're an IB-PYP school, which means our units of inquiry have central ideas and lines of inquiry. So my first few years, I remember starting each unit by looking at and unpacking those central ideas and lines of inquiry with my students. I'd often print out the central idea on the long banner, and I'd ask the students to gather around, and I'd ask them to notice the words they knew and discuss and look up the unknown words, and we'd write all over the banner and have all these ideas, and we'd usually stick it up on the wall and look at it for 6 weeks. And I used a lot of different ways to engage the students. So I would use silent conversations, and I'd use see, think, wonder, and there'd be small group and whole group. But after I'd finish that activity, I'd think, all right, now we are ready to learn. But without fail, we'd get to the end of a 6-week unit, and I would suddenly have several students who didn't know what those critical words meant, let alone how they connected. And I thought, how could this be? We made lists of words. We looked up those words 6 weeks ago, and I used them a lot. Has that ever happened in your class? That's my same symbol. Some of you probably use that too. Well, it turns out I was doing most of the thinking and meaning making, and they were just following along.
Yeah, and this has happened to me too. Possibly one of my least favorite terms is front-loading vocabulary. And yet I totally remember when I did this. I'd create these beautiful lists of vocabulary words with definitions and diagrams and have students memorize them all at the start of the unit. But this was a futile exercise. Students rarely remembered the definitions, let alone half of the words themselves. And there were just so many very discipline-specific vocabulary words or concepts, especially in science. And I knew that I needed a way to help students deeply understand the main concepts. Of course, I had dabbled in concept formation before. After creating the definition, perhaps we'd read it together and I'd provide 1 or 2 examples, and then we'd move to the next word on the list. But who did all the thinking? Not the students. And they often didn't understand the concept, not deeply anyway. And they most certainly did not own that understanding of that concept because they didn't do the thinking. They didn't create their own meaning. So both of us have come to realize that we were doing our students a bit of a disservice. We were thinking all of these important words as just that, vocabulary words that needed a definition rather than concepts, abstract ideas that would help our students make sense of, analyze, and interact with information in our complex world. And that is what we're going to dig into today. So as with all inquiry-based learning, we're going to use some guiding questions throughout our masterclass today, and here are a few highlights. What is concept formation and why is it important? How can I support students in building understanding of individual concepts? When in a unit should I focus on concept formation? And how can we transfer responsibility for thinking during concept formation to students? Today, you're also going to walk away from this masterclass with 7 concept formation strategies that you can take back into the classroom tomorrow, the next day, this week. Although we'll be using science as the context for all of our examples today, these strategies will actually work in any subject and across pretty much every grade level.
Now, before we dig into our first question, we do need to do a pulse check on our understanding of a fairly important term, concepts. Because concept is a concept we're quite sure you're already familiar with, well, we're going to not give you the definition, but instead we're going to give you some ideas that help you trigger that definition for you. So we're going to do a quick sort. Have you got a pen and paper ready? Okay. We're going to take a look and decide if these following words are concepts or not concepts. As you sort, I want you to ask yourself, are you placing them, why you are placing them in each group? Consider why they're common. What are their common attributes as you're putting them? So right now be thinking, where is gold? Is gold a concept or not? Mexico's population, concept or not? Life cycle, concept or not? So as you're thinking and you're putting those into the concept category, I want you to be thinking, what is a concept? So I'm going to give you a moment. I'm going to stop talking. And as you're thinking, if you want to pop your definition of what a concept is in the chat, that'd be great. Setting my timer. It's really hard to be quiet for 30 seconds. Sorry. So what do we have? I have lots of ideas going into the chat. So I see broad, timeless, abstract, universal, transferable, a big idea. They're abstract to varying degrees, not locked in time. They connect ideas. They're human constructs, not tied to specific place, time, universal. It's transferable. All right. A phenomenon, an idea that transcends time, situation, and context. Well, here's Lynn Erickson's definition. See if some of your ideas match with hers. A concept is an organizing idea, a mental construct. Concepts are timeless and abstract and universal, and they're abstract to different degrees, from broad to narrow. You could think of it that way. And they're represented by one or two words. Examples of concepts share common attributes. Can you see any similarities from the chat? I definitely can. And how did it go with your sort? This was actually our very first example of a simple yet very effective concept formation strategy that you can use in your classroom. It's called is and is not. So is a concept, is not. So that's our first strategy that you can put in your pocket to use this week. It is really as straightforward as having students sort examples and non-examples before working to explain the common attributes. I think of concepts as organizing ideas that sort of frame a set of facts, and they allow us to organize and make sense of and analyze and interact with the information in our complex world. Concepts are like how our brain automatically relates our experience in the world to a set of mental categories. They reduce the need to constantly relearn things. So here's an example. I'm a big documentary buff. I love to watch those. Maybe you do too. Have you ever watched a hawk soaring through the sky or perched quietly on a lofty branch, carefully watching for any movement below them? Then seen them swoop with incredible speed and accuracy to grab their prey and fly off with its grasped in its talons? Or what about orcas? Have you seen how they use their tapered heads and powerful tails to quickly move through the water, to ram their prey or to slap them with their tails, rendering their prey unconscious long enough for them to consume it? Both hawks and orcas have enhanced speed, strength, and sensory abilities. Eyesight in the case of hawks and hearing in the case of orcas. We connect both of these real-life examples to our understanding of the concept predatory adaptation. Even though both examples are quite different and they happen in very different places, but our understanding of predatory adaptations enables us to recognize new instances, even if they aren't directly related to hawks or orcas. I sometimes think of concepts as like the various hashtags or tags in our brain that we place on information to help us recall it and make connections quite quickly. So in this case, it'd be hashtag predatory adaptations, or hashtag apex predator, or hashtag don't eat me. Anyways, concepts are timeless. They transfer across time, across place, across culture and situation, and therefore they enable us to transfer our learning.
All right, so hopefully everybody's got a fairly clear idea on concepts now, because we're going to be using this term obviously all the way through the rest of our masterclass today. And our first question, our guiding question for this session is, what is a concept formation and why is it actually important? Gagne and Taba refer to concept formation as the initial stage of conceptual thinking, consisting of differentiating, categorizing, and labeling examples and non-examples to help develop an understanding of a concept. If we think of conceptual thinking like a set of stairs, where each step represents an increase in complexity and sophistication of thinking, we can see that forming is the first step to moving student thinking to a higher, more complex level of thinking. This forming step is used to bring clarity to a unit's concepts before students begin exploring conceptual relationships between concepts. The 7 strategies that we're going to share in today's masterclass can help students develop a shared understanding of the important concepts in a unit. So let's consider what this might actually look like in a classroom. Here's an example of, oh, sorry, Andrea, this is you.
It's okay. I was going to let you talk. So here's an example of a beautiful vocabulary list from a unit on mixtures and solutions, like a middle school unit. There are lots of very important concepts on this list that will definitely be needed in order to understand connections between them. And it looks fancy, right? Like, look at all those pictures and the colors. And well, if I gave my students this list and I have them memorize it at the start of the unit, we will be able to fly through the rest of the unit, right? And like the students throughout the unit will use it correctly in different contexts, right? And they'll be able to identify these concepts in new contexts, right? Right? No, wrong. Not gonna happen.
Instead, we actually need to provide students the time to explore multiple examples in order to determine the boundaries and dimensions of concepts. For example, what actually makes a mixture different from a solution? So let's try out our second strategy, and it's called concept quadrants, which is a super flexible strategy that can be used pretty much any subject area with students of any age, and is absolutely a favorite in my science class. Concept quadrants is a categorizing strategy, and it uses a 2x2 grid like the one on the screen with 3 examples and 1 non-example of a particular concept. Students actually examine the similarities and differences across the examples and non-examples in the grid, and this helps to deepen their understanding of the attributes or characteristics of the concept. So we're going to give it a go. We're going to work together. Here we go. We're still in that middle school unit about solutions and mixtures. So I need you to put on your sort of 12 or 13-year-old hat. And at this point in the unit, the students have been exposed to several examples of both mixtures and solutions prior to this moment. So have a look at this quadrant. I want you to think to yourself, what are these pictures of? What similarities and differences do you notice across this quadrant? You can pop some of those things that you notice in the chat. What do you see across these 4 images? Remember, we're in a mixtures and solutions unit. All right, we're seeing mixtures, we're seeing solids and liquids. They all have liquid in them. A healthy diet. Check out the bottom left one. And I'm not sure I want to eat it. Although it could be a healthy diet for someone.
Yeah.
Sources of food, yep. Examples of mixtures and solutions, different sizes. All right, I'm seeing some of my science teachers with the terminology already, but I'm pretty sure my 12 and 13-year-olds don't know those yet. That's okay. Morning meals. Definitely. That chicken noodle soup is what I like to eat when I'm not feeling so great. All right, so if you had to pick one of these 4 images to be the odd one out, which one would you pick? Pop it in the chat. You have to commit. There's no fence sitting here. All right, I'm seeing lots of coffees. I saw a bottom left, which is this bucket of rocks and sand and shells. It kind of breaks my heart that coffee's the odd one out because I do love coffee, but that's okay. Shells, all right. So we're seeing some people with different ideas. In the class, when we're together, I would have students discuss why they chose the odd one out and or which one they chose as the odd one out and why we chose it. And then without actually asking them anything about the concept itself, we would move on to a second example. So here's quadrant number 2 for the same concept. What are the pictures in this quadrant? What similarities and differences do you notice? Are they the same as the similarities and differences from the previous quadrant? Remember, there are 3 examples and 1 non-example of this concept. So this time I want you to pick the odd one out and why, and pop it in the chat. Which one do you think is the odd one out, and add why?
And Jess, I want to add, this is an example, again, 3 more examples of the same concept as the one we just looked at. So these are the same.
Exactly.
We have 6 examples of this concept and 2 non-examples.
All right, we've got a bit more of a mixed bag of people wondering what might be the odd one out here. And so we would have a conversation about what we're seeing, remembering we're in a mixtures and solutions unit here. And I'm seeing lots of things. So we're air because it's got only one type of thing. Other people saying the toys, they don't seem to mix. And elements of nature versus man-made. So there's lots of different ideas. All right, so we've been able to see in both of these concept quadrants mixtures that have multiple parts with parts that are visible, things that are not mixed together versus things that are mixed together. And in some cases, they can be separated, and in some cases, they can't. But these are the common attributes that we saw across what would have been the examples. And so at this point, I would ask my students, what is this concept? And for the most part, the students are going to have a great guess at what this concept is, because as you can imagine with your 12-year-old hat on, you probably actually don't know what this concept is called. Does anybody who's not in the know about the special name for these types of mixtures know or have a guess for what you might call them? For what this concept might be called? A state of matter, maybe? Any other guesses? Here's some that some of my students have come up with in the past. Bumpy mixtures, bits and pieces mixtures. I love this one in particular, party mixtures. It's kind of cool. Visible parts mixtures. All right, so we've got these names coming out where we can see they're forming this idea. They understand what the common characteristics of these particular examples are, but we don't actually have a name for it. And so at this point, although we've got these several clear examples and they've been able to identify these common characteristics and they've come up with some very logical and creative names, they don't have the vocabulary for this. So at this point, I'm going to say something like, scientists have a name for this kind of special mixture. It's called a heterogeneous mixture. And then we would work on co-constructing a definition and perhaps even look at a third concept quadrant in order to check if the definition and characteristics help us identify examples more easily. I also usually have my students create their own concept quadrants to share in small groups, which is also a great opportunity for assessment. All right, so that is concept quadrants. I also just want to point out something about concept quadrants because it is possibly one of my favorite strategies to use for concept formation. It does not have to be just images on a screen. You could use actual objects. You could use printed photographs, numbers, text, graphs. The possibilities are endless. And remember that the importance of concept formation is intentionally planned time in our learning journey, where students explore multiple examples of a concept in order to determine those attributes and boundaries of that concept.
Now that you're starting to understand what concept formation is and why it's important, you may be asking, how can I support students in building understanding of individual concepts? Well, it's really about planning for and intentionally allowing time for students to build those understandings, remembering that concept formation doesn't always look the same. We've already shared 2 different strategies. So one wonderful resource that we have to draw on is Rachel French's and Carla Marshall's book, Concept-Based Inquiry in Action, fondly known as the Green Book. The is, not, and the concept quadrants are just 2 examples of the strategies that we can use to build understanding of individual concepts. And we're going to try a lot more concept formation strategies from this book. So let's try one right now that's actually probably pretty familiar to a lot of you, but maybe you'll have a different lens of how you view it. And it's a Freyer model. So this is the 3rd strategy for today. A graphic organizer is used to place 4 distinct parts. We have examples and non-examples, characteristics, and a definition, which can be used in multiple ways. So sometimes we are introducing a completely unfamiliar or complex concept, and it can be useful to actually provide students with a definition and with characteristics, and then have students sort examples and non-examples of the concept. But if students have already had some prior exposure to the concept, students can develop their own definition and identify characteristics from the examples and non-examples. So let's try a Freyer model together. We're going to focus on the concept transparent material, which is typically explored in early elementary in a unit focusing on materials. Prior to this moment, students have been engaging with different materials during several sessions, and they've sorted materials into different categories. We're going to have a look at some materials. Here we go. So we've got plastic Ziploc bags, a mirror, some aluminum foil, black plastic food containers, cling film, a magnifying glass, a brick wall, and glass windows. Think for a moment which materials are examples of a transparent material and which are non-examples. Just take a moment to sort them in your mind. Like I said, it's early elementary. We probably sorted that pretty quickly. So you probably sorted it and it looks something like this. And we can go ahead directly from here and place this into our Freyer model, our examples and non-examples. So then we want to start thinking, what characteristics do all of the examples have in common? Take a moment to jot some down. Looking at the examples, what attribute do they all have in common? Someone wrote in the text, we can see through them. Here's some examples of what some of my students might say. Let's see if you wrote something similar. The light goes through them to the other side. They don't make shadows. We can see through them to the other side. Yeah, a lot of you are saying that similar thing about see-through and about light. So now at this grade level, we would co-construct a definition in small groups or as a whole class. But you can have a go on your own to write a definition, which is how we might use this strategy with older students. What would your definition of a transparent material be? So we might have come up with a definition such as transparent materials are see-through and light can go through them. Yeah? And you can see how guiding students through this process of concept formation is going to give them a greater depth of understanding about this single concept. Later, this will help them build understanding about materials, their properties, and their uses. Students have concrete examples to draw on, have interacted with the materials, and have understood their property from hands-on experiences, and have had opportunity to engage in meaning making for themselves. So much better than that vocabulary list, right? And we'll try to come back. I just saw some questions popping up. We'll try to come back to those near the end. For example, this one's about concept quadrant for older. I would use a Freya model with all grade levels. It's just a matter of how much support and time you would need. So with younger students, we do a lot more small group definition creating. With older students, you can have them work in pairs. In fact, let's look at a 9th grade biology class example of a Freya model. Here we go. Here the students are focused on photosynthesis, as it is one of the foundational concepts in the unit under study. Now, the concept itself is not completely new, but the concept is so central to all of the coming work in this unit that it's worth giving the time for students to have examples and non-examples to sort of freshen it in their mind, but also that they have a shared understanding of the term. Can you think about how you might use this strategy in your science class?
To quickly answer the question from before about using concept quadrants with older students, absolutely. They love them. I use them with all ages of students, from kindergarten right up to 12th graders and adults. They love them too. So it is super flexible and doesn't just have to be in science. Again, can be used everywhere. Hopefully you're starting to think about ways you might be able to use a Freya model or concept quadrants in your class coming up this week, because that's what we're trying to do, is give you some tools to use right away. All right, the 4th concept formation strategy, they're coming fast, right? Thick and fast at you. We're going to share today is called dimensions. And this is a ranking strategy. So different from the sort of categorizing strategies we've looked at before. And it's used to help students compare and contrast concepts using various dimensions on a low to high scale. Typically, the concepts are related in a broader context, and this strategy actually requires students to already have an initial understanding of both that broader context and the other concepts. The purpose of this strategy is for students to actually consider how different concepts may have some similar attributes. So for this strategy, as the teacher, you will need to provide students with the low to high scale, the concepts that are going to be ranked on that scale, the dimensions that the students will rank the concepts on. And because we're going to do several rounds of this, you'll actually need to have thought of different dimensions that you want them to be sorted on. So I'm going to share with you an example from a 10th grade chemistry class where students are exploring the groups of elements in the periodic table. So you can see them all there: the alkali metals, alkaline earth metals, transition metals, non-metals, halogens, and inert gases. Students had already investigated the characteristics of each of these groups, but the teacher wanted students to deepen their understanding of some of the key concepts for this unit. And so they used this strategy, dimensions, to allow students to compare the groups to each other using different dimensions. They started off with number of valence electrons, and the students ranked the concept cards, with each of the groups of the periodic table, along the scale from low to high. So you can see that they've taken those concept cards and ranked them. I should say that I would do this with students working in pairs or maybe in groups of 3, okay? But pairs is ideal.
Just
the dimensions along sorry, Andrea?
I just wanted to ask, when you're working with these students too, they're able to go back and look at their resources and materials. It's not like we're quizzing them in their brain, right? These are things that they can go back, because some of you might be sitting there like, oh, I wouldn't be able to do that. It's okay. You can use resources. They can use other resources.
Absolutely. Absolutely. We want them owning this thinking. So we want them to take responsibility for thinking about where they're going to place these things on this spectrum. Okay, so after they'd done valence electrons, the teacher then went ahead and changed the dimension several times. So atomic radius, ionization energy, electronegativity, electron affinity, oxidizing nature, metallic character, and so on and so forth. There are so many different dimensions that we could have students sort out or rank these examples. And each time they were ranked from low to high. And you can actually see how the relationship between the different concept cards is changing each time, okay? Can you imagine how you might use this strategy in your science class or in your unit of inquiry? The critical thinking and reflection going on during this concept formation strategy is going to help students make meaning of these concepts so much more than a definition just given to them by the teacher.
So Jess just shared a strategy that's about ranking different concepts. Let's go back to one. It's a favorite of mine, our 5th strategy today, and it's about categorizing, and it's called group, describe, and name. So for this strategy, the teacher will need to collect objects and or images, which are examples of the selected concepts. Students will group the objects, noticing and naming similarities or common attributes before naming each group. So just last week in my kindergarten classroom, we began to explore living and non-living things. I gathered a lot of real examples: a potted plant, a plant growing in water, a slug, a spider, ants. I went out and collected them, right before class, some sand, dirt, and water. And we also had a few images such as fire and a fish and a dog. In small groups, I asked the students to think about what they noticed. And I asked them to start thinking what went together. At first, there were many different connections, and my favorite, of course, being water and dirt go together because they make mud. But when I asked them to continue to think about how they might sort them and how they might put them together, we ended up with 3 groups. Animals, plants, and not animals and plants was the 3rd group. And we began talking about some of the common attributes in the groups. They needed food, they were alive. And in the end, I did end up telling them that the term scientists use are living things and non-living things. But this is just the start. We later went to the forest and we hunted for living and non-living examples, and then came back to the classroom to sort those photos that they had taken. And then as a check-in, I also had each student do their own sort as a seesaw activity. Now, this is just the beginning of our unit, and we'll be working to better understand the attributes of the concepts of animals, plants, living things, and non-living things as we explore more examples, but also how we start to see the connections across those different concepts.
All right, what concept can you see this strategy that Andrea just told you about working for in your current science or inquiry unit? Anyone got some ideas? How you might use group, describe, name. Throw some ideas in the chat how you can see that working.
I also love, I see teachers reaching out and saying, hey, I teach this. How can it go there? I love that you guys are working there too.
We'll try to address some of those at the end. Are you noticing how these concept formation strategies really help students wrestle with these ideas and allow them to solidify examples in their minds and also identify attributes and make sense of the definitions, all while allowing the students to do the thinking?
So I can think of another one. Here's our 6th strategy for supporting students in building understanding of individual concepts. It's analogies. And it's a simple strategy, and it requires students to use their factual knowledge to express a conceptual understanding or connection. We often use sentence frames to just support students' thinking. And I use this strategy with my 4th graders many times and at different points in a unit. So analogies such as these would have come at the very beginning of one of our units on the human body. A heart is like an apple because it's red and round. Bones are like tree trunks because they are long and strong. Skin is like a trampoline because it is stretchy. Now, students are mostly identifying a connection to the form. What's the shape, the color, the texture of this organ? Things they already knew and had experienced. So later, after some initial research into organs and body systems, we would start to see analogies like these. Skeletons are like a building frame because they keep us standing up and give us shape. The blood is like a delivery truck and trash truck in one because it takes things we need like oxygen to our body and takes away the things we don't need like carbon dioxide. Or muscles are like ropes and strings because they push and pull our bones to help us move. Here you can see how the students are beginning to make connections to the function of each organ. And later in the unit, we could also use this strategy to help us understand the human body systems. In what context could you think of using analogies as a concept formation strategy?
Because we didn't have time to share absolutely everything, Lillian has just taken the words right out of my mouth. I use this all of the time in middle school when we're talking about organelles or a cell as a system, and analogies is definitely a favorite. So I can see Lillian popped that in there before I could even get it out of my mouth. Bonding is a great idea. In your language class, fantastic. All right, one thing I want to talk about before we move to the next section is the role of examples or case studies in concept formation. It's really important that we are intentional as teachers about selecting quality examples and non-examples during this concept formation phase so that our students can clearly identify the attributes of that concept. I often find that my case studies can actually do double duty, where the non-examples may actually be examples of another concept. So remember back in the heterogeneous, homogeneous mixtures unit, those examples and non-examples actually serve as examples of the other concept. And the same goes for the living and non-living things. And remember, the case studies of concepts can come in many forms. So we can have photos, but we could also have objects or experiments or models or readings or videos or pretty much anything else you can think of. And this is super important. If we expect students to be able to identify common attributes of a concept, we need to provide multiple examples and non-examples of that concept. We absolutely cannot expect students to deeply understand a concept if they're only given one example. So imagine if during that early elementary materials unit, students were only given a piece of cling film as the example of a transparent material. Students might mistakenly conclude that all transparent materials are thin and flexible. That would be fair. So it is crucial to curate several quality examples and non-examples to allow students to explore those dimensions and boundaries that we've been talking about of that concept.
Okay, so we've already shared 6 strategies that you could use for concept formation in your class, and perhaps you're already thinking of context. You've shown me you've got lots of different contexts you could use them in. So I want us to consider what is the right time for concept formation. Concept formation can and should occur various times in a unit. Unlike the traditional list of vocabulary words that is typically introduced at the very start of a unit, a concept formation strategy could be used and concept formation happens when it is needed. Here's just a few factors to help you think about the timing of when concept formation should happen in a unit. Is the concept brand new? Is it in a new context? How abstract is the nature of the concept? how many concepts are being introduced in the unit, or how central or foundational are the concepts to the unit. There will likely be a handful of concepts that will require concept formation at the very start of a unit, and then as the unit progresses, there will be a need for more concept formation. For those of you that use concept-based inquiry to plan your units, here's a visual of what that might look like if you're using those CBI phases. The green focus symbol is where you're normally planning for concept formation. But each unit is unique, and the placement of concept formation in the learning engagements will be dependent on the students in front of you and their prior experiences.
All right, so this brings us to our final guiding question of today's session, which is, how can we transfer responsibility for thinking during concept formation to the students? Remember those fabulous start of unit vocabulary lists? Who created them? Who put the thinking into them? When the teacher creates that vocabulary list, the students are not really doing very much thinking when asked to look up words and just copy definitions. And as you've seen throughout today's session, using a concept-based inquiry approach in the classroom incorporates intentionally designed opportunities for students to actively explore boundaries and dimensions of a concept by using multiple case studies and to take on the heavy lifting when it comes to the thinking. And this usually looks two ways. First, students are immersed in examples and non-examples and work up from them to construct a definition of a concept. We call this an inductive approach to concept formation. Or the other way, students are exposed to a concept definition and then they use this to make sense of supporting examples and non-examples. And we refer to this as a deductive approach to concept formation. Depending on the complexity, novelty, and abstract nature of a concept, we make intentional decisions about how to help students experience and understand concepts and whether to use an inductive or a deductive approach to concept formation. For example, a middle school teacher designed this concept formation engagement to help students understand force and motion concepts. Since the students had already been exposed to the forces concepts, the teacher chose to provide concept cards with the concepts and their definitions. I know you might already be thinking, how is this different from a vocabulary list? Well, now the teacher actually asks pairs of students to rank their concepts against the concept of motion, from more to less related. Students were also asked to give reasons for their ranking and to provide a context for each one. Who's doing the thinking here? Take a moment to consider where you would rank friction on this spectrum. What reasons would you give for its placement? Would it be more related to motion or less related to motion? This is an example of a deductive approach to concept formation, and it's also our 7th concept formation strategy today. But as you can see, students are still doing the heavy lifting when it comes to thinking. This strategy is actually called a spectrum sort, and it's another ranking strategy and is particularly effective when the concept doesn't have any clear yes or no examples. And as you've seen in this strategy, students sort examples along the spectrum from least to most, justifying their placement of examples and discussing their thinking aloud with the class.
I want to point out too, all of these ranking ones that we've mentioned, they don't necessarily have like right and wrong answers, right? So it is when we ask you where you would place friction, you might decide like your justification is really the important piece.
And possibly to build on that, possibly one of my favorite things to do is after students have said why they've placed something on a spectrum, they might convince somebody else in the class that they actually need to make a different decision. And so that thinking and that dialogue of the students is super valuable and is what we really want students to be engaged in. All right. So all of our previous examples, apart from this one we just shared, today have actually used an inductive approach to concept formation, starting with the examples and non-examples and students building meaning up from there. And both of these approaches, inductive and deductive, to concept formation, allow opportunities for student thinking to be heard, to be seen, and ultimately to have the responsibility for meaning making put onto the students?
So keep in mind that the ultimate goal in a concept-based unit is not for students to be able to correctly define a concept. It's not just to select the right box on a test. Rather, it's for students to understand individual concepts and their connection to other concepts, and to be able to transfer that understanding to new contexts. So we cannot fully understand concepts without understanding their relation to other concepts. Now, as we wrap up today, and don't worry, we have some time for some questions. We've seen a lot in the chat. I want us to revisit our guiding questions from today's masterclass. Consider what you may now answer to some of these. What is concept formation, and why is it important? How can I support students in building an understanding of individual concepts? When in a unit should I focus on concept formation? And how can we transfer responsibility for thinking during concept formation to students? Now, I did mention, we've got 7 concept formation strategies that we've shared with you today. And our challenge for you is to actually use at least 1 or 2 of them this week in your classroom. So no matter what grade level you teach, no matter what subject as well, and you can even share what you've done on different socials with us. If you want to have some more concept strategies, concept formation strategies, or other strategies to use in your concept-based inquiry classroom, that green book is a great resource. And now we've got...
Thank you so much for joining us today.
Thank you, guys.
We've got a bit of time for questions, Rach.
Yeah, absolutely. Absolutely. Go ahead. So if you have a question, just pop it in the chat. We'd love to answer it while you are getting your questions in to the chat box. Thank you so much to Jessica and Andrea. It's always amazing to see how these strategies get utilized across different subject areas with different age groups. When Carla and I wrote the book, we always intended it to be that book that teachers will have sitting on their lap as they are planning. And I absolutely love seeing just all of the different ways that these strategies get used. So thank you so much for sharing the flexible way that they can be used in science. So concept formation is just really part of the focus phase of inquiry. It's one of the phases of inquiry. It's they showed you a model right at the beginning where you'll see that first step to thinking conceptually is concept formation, and we see that as the foundation. Carla had a great piece in the book to say it's like building a skyscraper. If you don't have that foundation of concept formation, whatever you build on top of that is likely to crumble. So
there were
if
some
you're interested...
questions.
Oh, yeah,
sorry, go ahead, Rach.
If you're interested in learning more about the about how to apply a concept-based approach in science, then Jessica and Andrea have developed a course. I'm just going to put the link to that in the chat there, so you'll see that now. If you're interested in finding out more about that, the next course starts on October 7th, so not too far away. So you can get yourself registered for that, and they in that course walk you through the complete process of designing a science unit, and you get to have a one-on-one call with one of them at the end to get feedback on your science unit as well. It is both self-paced video modules and weekly group calls with either Jess or Andrea.
Rachel, I do have a quick question that's really going to be for you. Where can we get the green book? Amazon?
Yeah, so quite often people are like, oh, can we order it directly from you? No, I don't actually have more than about 5 copies here. I have to order them myself. So the best place to order them from is either Amazon, and whatever your local Amazon is, or you can order them direct from our publisher, Corwin. So sometimes if you're ordering a group lot for your school, then Corwin will issue a discount, but you have to approach either Corwin in the US or Corwin Sage in the UK. So if you're looking to buy, if I'm buying 1 copy, I always get it from Amazon because I get it faster. But if I'm buying a number of copies for a workshop or for a school, then I buy them directly from the publisher. If you're wanting to know what the best contact for the publisher is, you can just send me an email and I can connect you based on where you live.
All right, we have a few questions that I think we can probably tackle. There's quite a few questions that are very similar, so I'm going to try and tackle them at the same time. Pete has asked, I know you don't think of learning as a learning experience to be a defined period of time, but we teach in time chunks. And so given a chunk of time, how often would you use both inductive and deductive approaches, which is a great question. Although we showed you concept formation strategies kind of in isolation today, it's actually pretty rare that I use a concept formation strategy all by itself. I actually combine concept formation strategies often. So as an example, we might do an is not sort, or I might do a group describe name, and then follow that with a Freya model or a ranking or a dimensions type activity, using both of those strategies on the same concept. Now, we don't have time to do that multiple concept formation strategies for every single concept. But remember, it's about gauging where your students are, their familiarity with those particular concepts, how foundational or driving they are for your unit or the lesson that you've got coming up. And then also combining that with their prior experiences and exposure. So I would often use an inductive and a deductive approach to concept formation in a single chunk of learning. But I equally might use two inductive methods as well. And that kind of then speaks to another question that I saw just below that said, inductive or deductive involves more thinking from the students. Which one? I would actually argue that both of them involve huge amounts of student thinking in different ways. And so as I hope we only demonstrated one deductive method today, but it really comes from the dialogue and the prior learning that they're going to be able to draw on into that conversation, and the dialogue that happens between the students that promotes a lot of student thinking when you're using a deductive method. Did you want to add anything, Andrea?
I think when I think about the age of my students, right? I've spent several sessions, several blocks of time talking about living and non-living with these kindergartners, whereas I could go up to high school and that would be a quick, 5-10 minute review. So it also really depends the timing that you spend. It depends on the student. So that's that prior experience. Yeah.
Mm-hmm. And that also relates to even the older students as well. So we've got older students, and we know we've got a ton of curriculum to get through, particularly if we're working at the very high end of the school. And they've got a lot of exposure to lots of these concepts before. So we may actually not need to do extensive concept formation on every concept again, because we have to trust that they actually have some good foundational understandings. And so if you're moving into a unit where many of the concepts are familiar, you could do a quick pulse check. You could do a quick sort, a quick engagement that doesn't take up tons and tons of time to actually see what examples students have to draw on or what they actually understand already about that concept. You may use a concept graph, which is another really great strategy where you're actually asking them to relate two concepts to each other and position concepts on a graph in relation to two dimensions, which is a little bit more complex, but would require some understanding of those concepts prior to that moment. So in those older grade levels, when you've got familiarity with those concepts, you can move through concept formation more quickly when it's appropriate. But given our example with the photosynthesis, grade 9, students have heard photosynthesis a ton of times before grade 9. But in a grade 9 or a grade 10 unit that really has a lot of solid foundations based on understanding photosynthesis, you're going to need to spend time there to make sure you've got that common understanding before you can move forward, because you could end up halfway through your unit and realize you've got half your students who don't actually really fully understand photosynthesis.
I wanted to build on what you were saying about the question about deductive versus inductive. One thing that when we typically talk about concept-based inquiry, we advocate for an inductive approach. So what you're hearing us say right now is saying, no, both are great. It's actually true that in this instant, when it comes to concept formation, we do balance those a lot more in this phase, in this part of the learning. But we overall advocate for an inductive approach. I also want to point out that in both the inductive and deductive examples, we're talking about teachers doing a lot of gathering of those examples and non-examples, where we're or we're giving like sentence frames and graphic organizers, we're doing some of this work to help our students focus on that learning piece rather than, you know, I've used a Frayer model long ago, and I was like, yeah, fill out this Frayer model, thinking that was what we were doing, right? Whereas in what we're advocating for is giving them some of those examples and non-examples to use in their Frayer model. Or, as Jess mentioned, maybe I do use the Frayer model at the end of another strategy. So it's this fun mix that we use, and we really just need to tune into what our students need in order to do that well.
Mm-hmm.
We do have...
yeah, and you can definitely have students create examples using any of these strategies after they've already had a go, potentially using the curated examples that you've provided. You can absolutely have students creating their own. And again, that's just a really great way for a quick pulse assessment check. I did see one question that was about that they missed 5 minutes at the beginning, Rach, but everyone's going to get the recording. So don't worry if you missed a little bit of this masterclass. The recording will come into your inbox because you were registered. So you'll be able to watch us again if you like.
You can also share that recording with anyone else who you think might benefit from hearing from it. So if you have people in your science department who you think would benefit from seeing some of those strategies, or if you want to sit down and watch it as a team, you can do that with the recording. There was another question about the difference between the spectrum sort and the dimensions. They are very, very similar strategies. But I think about it in terms of the spectrum sort is often sorting examples, sorting case studies. So in the example that we saw, we were sorting different objects in terms of most transparent and least transparent. I've done sorting food from most healthy to least healthy, sorting activities from most safe to least safe. But in dimensions, you're comparing concepts with concepts. So you're not looking at different case studies there, you're looking at concepts. And then in the dimensions activity, there's an intentional choice on the part of the teacher to change the concept out and now compare it to a new concept. So that's that dimension at the top. So there's a multi-sort happening where we will compare it to a new concept and then compare it to a new concept. So often I wouldn't use dimensions with quite young students. I'd stick with the spectrum sort. Students of all ages can use the spectrum sort, but dimensions are certainly appropriate for older students where they can start to compare not concepts with case studies, but concepts with concepts.
I often find dimensions also really helpful. I tend to use it more in social studies, and because it seems sometimes a lot of the science pieces like, well, it's this or this, but when I get to social studies, I find a lot of times that I use that personally as well. We had a question about assessment, and I just want to mention we've used that word a few times when we've talked about these different ways of concept formation. One way is we've used, for example, a check at the end of a concept formation as, hey, let me assess. I'll do this Frayer model. Did our students understand the concept? I'd also mention my example about the living and non-living. My way of doing that sort in those small groups with students, it was also my chance to pre-assess their knowledge. Do they even know these things? What do they know about them? So it's a really great opportunity to see what it is that we need to learn. For example, I realized, well, we're going to talk a lot more about needs because they're not identifying that plants and animals need water. So that was my chance. I don't tell them any of that. I just keep that as my pre-assessment of when do I introduce these ideas, the needs of plants and animals in my unit. So that it's very helpful to use different types of assessment, and using the strategies as assessment also works.
All right.
Okay.
Thank you.
Thank you so much.
I was just going to say, just remember that these strategies, obviously we've been looking at science as a focus today, but these strategies can be used across all subject areas and across all grade levels. I know that there's lots of familiar faces here, which is lovely to see. Thank you for showing up and supporting. Lots of people who are doing the trainer certification this year and who've done it in the past, who are coming from all different subject areas. So I think it's really helpful to just see how these strategies get used in different subjects.
Okay. Well, thank you so much for joining us today. We love sharing these strategies. We had a huge list of other examples that we You know, even right up until a few days ago, we were like, we have to chop it down. We have to chop it down. We're not going to make it. And you can see how passionate we are about this concept formation in science, where we've got a huge amount of vocabulary, discipline-specific vocabulary to get through. But placing that ownership on students for their thinking is so important and can be done in a fun and engaging way so that students are actually going to take that meaning away and own it. So thanks again for joining us. Like Rachel mentioned, we do have a course starting really soon, and we would love you to join us. Andrea?
Yes, everything you just said. I'm really excited that so many teachers are here, and I am excited to hopefully see some of you around the teaching sphere. That's a place.
Happy Sunday, everybody.
Thank you.
Thank you.